Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube.
Good morning. Today I am discussing about smithy and forging operation. Fuels used in furnaces. Many types of fuels are used in the furnaces are employed in forging work. All these fuels can be broadly classified into three groups. One is the solid fuel such as coal, coke, charcoal, etc. Liquid fuel, they include different types of fuel oil, and gaseous fuel, natural gas and producer gas. Forging material, the material processing or ability to sustain substantial plastic deformation without fracture, even in presence, often soil stress can be forced easily. Wrought iron, low and medium carbon steels, low alloy steel, aluminium, magnesium, and copper alloys are common forgeable material. Austenite and martensite stainless steel nickel alloy can be forged with some difficulty. Forging temperature. Forging material must be heated to a temperature at which it will possess high plastic properties both at the beginning and at the end of the forging process. If the forging operation is finished at lower temperature, this leads to cold hardened and cracks. With excessive heating, the forging suffers oxidation and much metal is wasted. Approximate temperature for forging and following common metals at the beginning and at the end of forging process are under. One is the wrought iron, temperature in degree centigrade at the beginning 1300, and temperature in degree centigrade at the end 800 degree centigrade. 2, that is the low carbon steel 1250 to 1300, and temperature in degree centigrade 800 to 850. Hard high carbon and alloy steel 1100 to 1150, Y825 to 875, brass bronze 950 and another one 600. Aluminium and magnesium alloy 500 and 350. The temperature of heating of steel for hand forging can be estimated by the heat color of the heated steel given. One is the faint red 500, blood red 650, and cherry red 750, bright red 850, and salmon 900, orange 950, yellow 1050, white 1200. So that is the color and approximate temperature in degree centigrade. Forging operation. For giving desired shapes to the products, the following operations are used in a smithy shop: upsetting, drawing out or drawing down, cutting, bending, punching and drifting, setting down and finishing. Upsetting or jumping. Upsetting is in the process through which the cross section of a metal piece is increased with a corresponding reduced in its length. When a metal is sufficiently heated so that it acquires the plastic stage, it becomes soft. If some pressure is applied to it, the metal tends to increase in its dimensions. at right angles to the direction of application force, which corresponds reduction in its dimension parallel to the line of action of the set force. The particular part in the bar shape where set increase in the cross section is desired is heated till it acquires a fully plastic state. The hot portion of the bar is kept an anvil face and the bar hammered at the top. Hammering in this operation is done either by the smith himself, if the job is small, by means of a hand hammer, or by his helper in this case, in a case of big jobs when heavy blows are needed, by means of a sledgehammer. Drawing out. This process is also known as a drawing down. It is exactly reverse process to that of upsetting in the sense it is employed when reduction in thickness, width, or both of the bar is desired with a corresponding increase in its length. The desired effect is possible to be obtained by the use of either the pin of a cross pin hammer, a set of fullers, or a pair of switches for round bars only. The process of heating and cooling the length not required to be drawn is the same as in case of upsetting, but the selection of the above tools is governed by the shape of the cross section of the stock. The amount by which the increase in length is desired also required finish shape job. Cutting. Cutting of metal in hot or cold state is done by means of hot or cold chisel respectively. This operation is required in removing extra metal from the job before finishing it. Cutting required length of pieces from a stock, splitting a metal piece into two at a desired location, and similar other requirement. Enough care should be taken while cutting cold steel, since there is very likelihood of the chips flying off in different direction and causes injuries. Also, more power and time is taken in cold cutting as compared to hot chiseling. If very thin section is being cut, even cracks may sometimes occur. Cold cutting is therefore preferred for the thin section only, such as rods of thin section and sheet, etc. Especially alloy steels should never be cut cold. Workshop practice for hot cutting of steel should be heated to red in the furnace and then cut. The usual temperature for cutting 850 to 950. Then bending. Bending of the bars, flat and other similar stock material is usually done in smithy shop. This can be done to produce different type of bend shapes such as angle, oval and circles. Any desired angle can be made through this operation. For making a straight angle bend that particular portion of the stock which to be subjected to bending is heated and jumped on the outer surface. This operation is carried out on the edge of the anvil or on the perfectly squared edge of a rectangular block. After bending, the outside bulging is finished by means of a flatter and inside one by means of a set hammer. Curved shape of bends are formed on the horn of the anvil. For mass production of particles made through bending, particularly when dimensions accurately in is a must, jigs and fixer are designed to help in performing these operations quickly and efficiently. This result in a considerable saving of time and labor. Punching and drifting. Punching and drifting are used for producing and finishing holes and preparatory for producing other shapes. Punching should be done in two stages. In the first stage, the workpiece is kept flat on the anvil and holes performed halfway through. Then job is turned upside down. The application of punching producing the slot, a number of holes are punched and the remaining excess material is cut out using chisel. The slot may be finished or drifting or may be finished by filing when cold. Setting down. It is localized, drawing down or switching operation. Usually, the work is fullered at the place where the setting down is effected by the set hammer. Forging processes. The processes of reducing a metal billet between flat dies or in a closed impression dies to obtain a part of predetermined size and shape are smooth forging and impression. Die forging respectively. Depending on the equipments utilized, they are further subdivided as under. Smooth and die forging. It is also known as a flat die or open die forging. It is simply relatively inexpensive and allow the production of large varieties of shapes. The final shape of the forging depends largely on the skill on the smith. Hand forging is employed only to shape a small number of light forging, mainly to repair shops. This is done by hammering the piece of metal. When it is heated to proper temperature or an anvil, a hand hammer or a sledgehammer is used for striking. Power forging, large machining parts which cannot be forged by hand forging, use of power hammer and press employed to do the job. Hammer forging, actually hammer forging machines which work on forging by blow are called hammers. The heavy falling part of the hammer is called the ram and the rigid support is in the form of anvil block. The power hammer may be gravity fall type or a higher striking velocity type, such as mechanical hammer, air and steam hammer, etc. These hammers are available with different ram weight and different blows rate per minute. Press forging. Forging presses for smithy work are usually of the hydraulic type. In press forging, pressure or squeeze is applied to the raw material and intensity of this pressure increases as the plastic metal resists deformation. As the pressure applies Squeeze the metal slowly compared to blow hammer. More time is available for the flow of metal being forced. Impression die forging, it is employed for more complex shapes of greater accuracy, large quantities of identical forging, as well as a special item with quality and economy reason. Drop forging. Three types of drops hammer are used in making drop forging. They are board or gravity type, air lift hammer and power drop hammer also called the steam hammer. Press forging, it is done in press rather than with the hammer. The action is relatively slow quizzing instead of delivering heavy load. Machine or upset forging, forging of the ring or rod types with all kinds of heads and shoulders such as bolt, nut, washer, collar, pinion, gear, blank, etc. can conveniently produced in forging machines. Large number of small identical items can be machined, forged. Okay, machine or upset. This one. Another one is the heat treatment process. Why heat treatment is necessary? To improve the strength. Steel and other alloys have a large number of applications in engineering practices under varying conditions, requiring different properties in them. At one place, they may be subjected to bending, while at the other to twisting. They may be required to withstand various types of stress and as tool material to have hardness, especially red hardness, combined with toughness along with non-brittle cutting edge. They may be required to bear static or dynamic load, revolve at extremely high speed, operate in highly corrosive media. An extremely hard skin with a tough core subjected to fatigue and creep. Such varying condition of their application require this material. But a material may be lack in some or all of these properties either fully or partially. These deficiencies are fulfilled through the process of heat treatment. Generally, all steel can be heat treated as per need. Aluminium is the only ferrous metal which can be effectively heat treated. The process of heat treatment involves heating of solid metal to a specified temperature, holding them at that temperature, and then cooling them at suitable rates in order to enable the metals to acquire the desired properties to the required extent. All this takes place because of the changes in size, form in nature and distribution of different constitution in the microstructure of these metal. All heat treatment processes therefore comprise the following three stages of component: heating the metal to a predefined temperature, holding is that temperature for sufficient time so that structure of the metal becomes uniform throughout, cooling the metal at a predefined rate in a suitable media so as to force the metal to acquire a desired internal structure and thus obtain the desired properties to the required extent. All this takes place because of the changes in size, form, nature, distribution constituents in the microstructure of these metals. Okay, this is the end of lecture. Okay.
Last, if you like my video, you have to subscribe. Okay, thank you.